play. So anyway, the answer to this one if we do this problem, when we finally get down to the answer, it might not exactly look like a slope, but it sort of is. But those are pre-calculus and calculus ideas. But we can still try to do it. It's kind of tricky. You ready? I want to do the difference quotient to this function. Well, let's see. What does the difference quotient tell me to do? Let's see. It's always this. So the difference quotient says go to your function and plug in an x plus h. That's what it says. So that's hard to do though. Watch.
Do you do it?
I got to plug in an x plus h for all the x's, right? Look what I get. I get x plus h squared plus 4 times x plus h minus 3. That's me plugging x plus h into the function. And that's the first part of this. What do I do next? Minus the function itself, just the function with an x in it, which is just the function itself. So now I have to minus the function itself, the function with an x in it. Okay. Are you guys okay? Can you see that? Can you see that that's f of x plus h minus f of x all over h? And you have a mess on your hands now. I mean, this is a complicated bunch of algebra here, and the thing is, it simplifies greatly. But to see it simplify greatly, you got to do some algebra. You have to FOIL this out. We've done a little bit of foiling, and you should know how to FOIL, but sometimes students make mistakes. I'm going to come over here where I got a little more room. On my scrap paper, I'm going to FOIL this out. You understand? X plus h times x plus h. I think I've tried to tell you before in the last couple days that there's a pattern to this, but the pattern is, I don't know. Let's just do it. You multiply the x's, you get x squared. You multiply those guys, you get an xh. But look what's coming now. Another xh, right, you guys? And then finally an h squared. So the pattern that always happens is you get that first term squared, you get that last term squared, and you get this middle term, which is always 2 times the x times the h, 2xh. So that's just the first part. Hold on, that's me foiling this out. Let me write all that down. That's x squared, 2xh plus h squared. That's me foiling that out. The rest of this is not too bad. Distribute a 4, 4x plus 4h. 4x plus 4h minus a 3. All right, I distributed that all out, foiled it out. What's coming next? Subtract all that, which means I'm going to distribute the negative sign. Negative x squared, negative 4x, and positive 3. You with me on that? All over h. All right, that was kind of the hard part. This is fun. I think canceling stuff is the funnest part of math, don't you? Here comes the fun part. Canceling stuff. Like, oh no, I got this mess. Wait a minute, watch how fun this is. X squared cancels with a negative x squared. Look at this, positive 4x. That cancels with this negative 4x. See this negative 3? It's going to cancel with this positive 3. It usually happens like that. A bunch of stuff cancels. And there's a little bit more to do. Let's figure out what we got left here. What do we have left here? We have this 2xh plus this h squared plus this 4h. Are you guys with me? That's the things that are left. That's the terms that are left in the numerator. It is all over h. And you can cancel that h. You've got to do it correctly, though. Let's see. There's a couple ways I could say this. I could say that the h is divided into each of these terms. And so you can divide the h into him, into him, into him, and basically you're canceling that h, and that h.
You just take an h out.
Another way to say it is factor an h out front, and when it's factored out front, then cancel it. There's sort of two ways to talk. I can divide the h into each term, which would cancel the h out of each term. Of course, that does leave me, what does that leave me with? If you just do it, just think about it. If I cancel this h, I'm left with 2x. If I cancel one of these h's, I'm left with 1h. If I cancel this h, I'm left with a 4. That is the answer. Now here's the other way to think though. You factor that h out, what are you left with if you factor it out? 2x plus h plus 4, right? And then it's all over this h, and now you, because it's a factor and it's factored out front, you can cancel it, and there's my answer. 2x plus h plus 4. Which doesn't exactly look like a slope, like but again, this guy isn't exactly aligned with a slope. So that concept of slope is still behind the scenes, but it's hard for, we can't really make that connection too well now with this problem. So anyway, it's an exercise. Some of this stuff is an exercise in skills and algebraic skills, and some of it has greater, deeper meaning. Some of it's just kind of a good exercise for some future courses. Okay, I'll tell you, I really think I want to launch into this 2.4 here and give you a good lecture on 2.4. There's a lot of good stuff there, so I'm going to leave this. Are you guys okay? Any questions? Again, a couple of these in the 2.2 homework you could try. So chapter 1 to me is, well, there's some other ideas, but the big idea was lines and slopes was in there. And linear functions. But when we move into chapter 2 here, we started thinking about other kinds of functions. In 2.4, I really want to outline 4 or 5, I think 5 functions that I want you to know. I want you to memorize these sort of 5 functions and their shapes. These are basic functions here. Here's one. I want you to know this basic function. F of x is x squared. We've sort of talked about him before. When he's squared, he's not called linear. The word is quadratic. We'll investigate quadratics, have their own chapter. Chapter 3 is quadratic. So I'll really explore this in much more detail coming up next week. But right now, I want you to just know him. He's also, I called him a quadratic. His shape is called a parabola. And he's the most basic parabola. He's this guy. He lives right here. He sits right here at 0, 0, and he opens like this. He's just a very basic parabola, x squared. Now, I just wrote that equation and wrote that picture, didn't I? You saw? And is that magic? I mean, what's between having the equation and the picture? I mean, what explains that magic? Do you know what explains that magic? Or is it magic? I mean, I want you to know how does an equation become a picture, a graph? And I think I sort of said that the first day. If you make a little chart and plot a bunch of points, that's how it happens. I skipped all that because I kind of don't want to take the time to do that. But it's good for you. It's good for you to know at any point. Listen, I'll just do, I got several functions I want to get up on the board here, but you can do this. You should do this. And so I'm going to watch this. I'm going to put -2, -1, 0, 1, and 2. Do you see what I'm doing? A couple negative x's, a couple positive x's, and I just want to plug these in and plot the points. What happens when you plug a -2 in there and square it? You get 4. You do get 4. -2 times -2 is +4. What happens when you plug a -1 in there and square it? You get a 1. If you plug in a 0, you get a 0. If you plug in a 1, you get 1. If you plug in a 2, you get 4. I might have already done this with this guy. I just plotted these points. When x is -2, we're up here at 4. When x is -1, we're at 1. 0, 0, 1, 1, and 2, 4. Are you following me? And it has this curvy shape. It's a parabola. So You know what it's kind of like? You know how, like on my driver's license, it says Scott Smith, and it has my picture, and it has some stuff like I'm 5'8", 200 pounds, you know? That's kind of what this is. Look, this is his name, this is his picture, and this is some details about his guts or whatever. That's his name, that's his picture, that's his, some statistics, data. What I want you to do is I want you to just memorize that equation is that shape. That's what I want. Again, behind the scenes, you should know how that happens. It happens through this chart. But I want you to just memorize that equation is that shape. Okay, here's another one I want you to memorize. F of x is the square root of x. It's not, this function squares x, this function square roots x. I kind of like to refer to him as his cousin. It's different. It's a different function, but it's kind of related because this one's squaring and this one's square rooting. Again, I can make a chart and plot points. If you don't mind, I wonder if you'll just believe me if I say it's this. It's this shape. That's the function. If I plotted points, it's this shape. What I want to say is I want to say to you that it's sort of a sideways version of this. You know, this is a parabola. This is sort of a sideways parabola, except, look at this. See it now? Do you see a sideways parabola? But it's not a sideways parabola. Remember, I added that other little part there. I mean, really, it's half of a sideways parabola, isn't it? It's half of a sideways parabola. So he is kind of related to him. This is a parabola. That's a sideways parabola. Well, but it's half of it. It's the top half of a sideways parabola. So they're kind of related. But I just want you to memorize, bless you, the equation is that shape. That equation is that shape. That equation is that shape. A couple more, please. Look at this one. F of x equals x cubed. That's x to the third power. You know, that's x times x times x. That's x cubed, or x to the third power. We'll study this guy in a little more detail up in chapter 4. But right now I'm just getting you used to some basic functions. He looks like this. Look at this. He comes up like this. He kind of levels out for just a moment and then heads on up like this. I don't know. I kind of think of him as this snake. He's kind of like a snake snaking through there. Whatever. One thing you can try to understand, again, watch, rather than making a chart and plotting points, if you don't mind, watch, if I plug in a 0, what do you get when you plug in a 0? 0, and that's that point, 0, 0. Watch this. If you plug in a 1, what do you get when you plug in a 1? You get 1 cubed, which is 1 times 1 times 1, which is 1. Okay, all right, thank you. That's not a great job, but that's okay. When you plug in a 2, what do you get? 8. You do get 8. 2 times 2 times 2. What it is, 2 cubed, 2 times 2 is 8. So that's way up there. But watch this. On the other side, when you plug in a -1, it's -1 times -1 times -1. I mean, there's 3 of them there, and therefore the answer is -1, right? As opposed to over here, when we had -1 squared, it came out +1, right? Well, -1 cubed comes out -1. And what about -2 cubed? -8. So you can see why it's down here. So it's down in this quadrant. Right. It's different than him. And you can kind of understand exactly why when you plot points. And when you plot points, there's no more mystery about this. It's never really a mystery. That equation is that shape. And plotting points helps you understand that. That equation is that shape.
They'll always be in those same quadrants?
Well, that equation is that shape. That equation is that shape. See, the thing, what I'm trying to do, I'm trying to teach you some basic shapes, and I got a couple more. But then, they're not going to stay right here. You're right. Then I'm going to learn how to shift them. And I'll be able to shift them left and right and up and down, and then I can move these things all over the place. So then they'll be this shape, but they might be moved way over here or something like that, right? So first we're learning these basic shapes. Let's see, who else do I want? How about this one? F of x equals, his cousin, watch this, his cousin is the cube root of x. Now, this is a square root. You guys, when you have a root, there's a little index. There's a little index in front of the root that tells you whether it's a square root, cube root, fourth root, fifth root. Okay, they're all roots, but you put a little index up there. Now, wait a minute. When it's a square root, you don't put an index up there. You don't put a little 2 there to tell you it's a square root. When it's a square root, we all know it's a square root without the little index 2. You follow me? When it's a cube root, there's a little index 3 there to tell me it's a cube root. Anyway, the cube root is sort of the cousin of the cubing, just like the square root was sort of the cousin of the squaring. And so guess what? He's a sideways version of him. He's a sideways version of him. So let me just tell you, it's this. It's this shape. It's this guy. It's sort of a sideways version of this guy. You know, I'm really just asking them to memorize shapes, although if you're perplexed, what the hell? Why is that shape? You make a chart and plot a bunch of points and you won't be perplexed anymore. Well, that's pretty good. Hey, I think I got one more. Oh yeah, one more. Maybe 2 more, maybe 1 more. This guy, this is the absolute value of x. Let's take a little talk about that. Do you know about absolute value? You know what the absolute value of 2 is?
2.
Yeah. What's the absolute value of negative
2?
2. So, what's your definition of absolute value?
The positive.
It makes things positive. That's a good definition. Absolute value takes whatever's inside and makes it positive. If it's already positive, it's still positive. If it's negative, it makes it positive. That's a decent explanation. There's other. But that's what absolute value does to the input. So it just makes the output positive. Some students think, oh, you can't plug negative. You see, you're allowed to plug positive or negative numbers into an absolute value. But what does absolute value do to those negative numbers? It makes the output positive. It makes all the outputs positive. Right. So if I made a little chart and plotted some points, I would see a lot of positive y values here. And they would be, let's try it. If x is 0, what do you get when x is 0?
0.
Thank you. When x is a 1, 1. When x is a 2, 2. When x is a 3, 3. You know what that is? That's this line. That's this diagonal line. Over on the other side, though, what happens when x is negative 1? It's still a 1. What about negative 2? It's a 2. So it's also this diagonal line. So this absolute value function, sometimes I like to refer to it as this V-shaped function. See it? It's this V-shaped function. Those are a couple of lines there. It's this V-shaped function. I want you to memorize that shape, please. So that's it. That's it. There's 5 of them. 1, 2, 3, 4, 5 functions. I'd like you to memorize their basic shapes of these 5 functions. You think you can do that? Mm-hmm. Okay, good. I think so too. You got some other stuff. You got some formulas. You got some other, but not too hard. You might have known about some of these already, but if you didn't, they're kind of, and you can, I don't know, you can think of them like I do. Like these two are sort of related, and these two are sort of related. This guy's just kind of different. He's the absolute value. He's this V-shaped graph. Okay. So then, I've got some good notes for you about shifting or transforming these functions. These are called transformations, and this is all in 2.4. So, yeah, like I said, some of these sections contain a lot of information. 2.4 is please memorize these basic shapes, and let's learn how to transform them or shift them. So, like I said, the book might refer to this as transformations. Maybe they say translations. Maybe they say reflections. This is a lot of things that we can do to these functions. We can transform them, translate them, reflect them. I mean, I don't know. Those are a lot of fancy words. I'm going to use different words to tell you the truth. I'm putting those words up there because I think that might be the way the book talks a little bit, maybe your homework. I'm going to say shifts. I'm going to call them shifting. Okay, I'm going to say this. I'm going to say shifting and flipping. That's what I'm calling this. So here we go. If I take any, these are my notes. These are pretty good notes. If I take any function plus some number c, this is just some number c. Now, I can explain, I can just tell you the answer, or I can try to explain it. I'm a teacher. I like to explain things. I like to explain things. And so I want to say this. A function is you could think of this f of x as a bunch of y values. A bunch of y values, you could think of a bunch of y values. And if you take all these y values and add some number to them, what's going to happen to all these y values if you add 6 to them all? They're going to move up 6. That's exactly what happens. So when you add a number to a function, you're shifting the whole function up. 6 or 10 or whatever that number is. I'm going to write my notes here. I'm going to say shifts up c units. Whatever this number c is, it shifts up c units. That's what this does. It's very logical. I just explained it to you. Cool. Well, check this out. What if you have f of x minus some number c? Come on.
Goes down.
Thank you. Good. It takes the whole function and shifts it down. Like this picture. See this? This is good old x squared. But if I put minus 4 on it, what would happen to it?
Goes down.
The whole thing would shift down 4. The whole picture would shift. You'd have this picture. It's easy. It's cool. I mean, we kind of stumbled into that the other day. So I'm going to put that in my notes. Shifts down c units. Down c units. Okay, here comes something else. This is a little different. This time I'm going to write this. I'm going to write f of x plus c. But look at this now. The plus c is in there with the x. So it's not out on the end of the function. It's in there with the x. When we get to some examples, you'll see it a little clearer. But I'm adding kind of in there with the x. And so since I'm adding it to the x kind of, not off there to those y values, I'm adding it to the x. I'm sort of moving it in the x direction. And I might think that I'm moving it to the right or left. Now hold on. The funny thing about the right or left shift is that it's opposite of what you think. So if it's plus c, that's to the left. You might think it's to the right, but it's not. It's to the left. The right and left shifts are opposite of what you might think. So the x plus c this is shifted to the left c. And if you had an f of x minus c, that would be shifting it to the right. That's shifting it to the right. C units. Shift to the right. C units. That's true. Those are true facts. And then you got to memorize those ideas, I guess. And you memorize those, you memorize all these, and you're pretty powerful. You can graph some cool functions. We'll get there. Listen, just a couple more ideas. This is the shifts. I can shift up, down, left, or right. Those are the shifts. The other thing I can do is I can reflect. What that book would call a reflection around the x-axis. A reflection around the x-axis. Now I call that flipping it upside down. Can't you just flip it upside down? Yeah. The book calls that a reflection around the x-axis. but you can flip it upside down, and I don't know if you know how to do that, but I'm about to tell you. If you multiply a negative in front of the function, by the way, you can think of it like this. All those y values that you had, all those y values just got negated. If all those y values, they just all got flipped. All those y values just got negated. So a negative sign in front of the function, I'm calling that flips it upside down. Again, what would the book call that? A reflection around the x-axis. They use that accent, they do everything. Yes, all nice and proper. But I like to say it flips it upside down. What about this one? What about if you stick a negative sign on that x, not in front on the y, but kind of on that x? Then you're sort of flipping the x's, and I call that flipping it sideways is what I call it. Flipping that thing sideways. But you could call it a reflection around the y-axis. But you could call it flipping it sideways, baby. Flip it sideways. There's a little more to this that the book includes that some semesters I include it, some semesters I don't include it. Now I'm worried. I wonder what's in your homework.
They'll probably be in there.
We'll find out. But there's a little more to this, and that's if you multiply by a number, but multiplying by a 3 so this is adding and subtracting, or multiplying by a negative sign, which flips it sideways. But multiplying by a number 3 actually stretches it. And multiplying by a 1/3 compresses it. So we can have this parabola, if you stretched it, it could become a very skinny parabola. Or if you compressed it, it can become a very wide parabola. Are you with me? Now that's true, and all that can happen. I'd like to leave that for pre-calculus. I mean, those are details that...
What is it, everything greater than 1 makes it something?
Multiplying by a number bigger than 1
Just for our homework.
stretches it. Multiplying by a number less than 1 compresses it. Vertically. I think if you do that, let's not talk about that right now. I mean, that gets kind of tricky. I could tell it to you. I could explain it all to you like I do, but I just kind of don't want to. Here's what I want to do now. With all that knowledge and all this knowledge, the kind of questions I expect you to be able to handle on a test are something like this. Can you please graph this function? F of x equals negative x minus 4 squared plus 11. So, all of a sudden, this is kind of a complicated function, but this is the ticket. I mean, I just explained to you the easy, cool way to do this. I mean, the harder, uncool way to do it is make a chart and plot a ton of points. If you make a chart and plot a ton of points, and if they're the right points, I mean, you'll get a good picture of this. But you don't need to. I try to teach you stuff that avoids that. I mean, I try to teach you the good stuff. And the good stuff is memorize his shape. Which one is he? Out of my 5 shapes, which one is he? He's the x squared. That's the key, right? Do you see it? It's the x squared. So it's this guy. And now, so it's this x squared, which means he's this parabola right here. He's this parabola right here, but he's been shifted. How has he been shifted? And what I like to do is on a test or a quiz, I might even ask you, use some words and tell me what's going on. So what about that plus 11? What do you think that's doing?
Shift, moving it up.
You think that's a shift up? Shift up 11. Okay, good. Thank you. Anything else you see going on? What about that negative 4 in there? See, that negative 4 is in there with the x. You see it? It's being added or subtracted to the x, which in my notes, that's this scenario. And if it's a minus 4, it's to the right. Yeah. So that's to the right 4. The plus 11 is out on the end. That's very clearly a shift up 11. The minus 4 is in there with the x, so that's to the right 4. To the right 4. Anything else you see?
A negative makes it upside down.
Oh, a negative sign in front of it makes it upside down, she says. Okay. Okay. So she's right. And I like pointing all this out. I think this would help you if you, on a test or quiz. I think I even asked you, please use some words to describe these shifts. And I'm looking for these words, kind of. And then I might ask you to also graph it. So you just very quickly, here's how you graph it. You guys ready? It's this picture shifted like we described. You know, it is the whole picture being shifted, but you know what kind of helps? It kind of helps maybe to zero in on just one point and watch it get shifted. And what I kind of mean is maybe this point. This point, it's the whole graph, but let's talk about this point. It gets shifted up 11. It gets shifted up 11. So now it's here. Wait a minute. Then it got shifted to the right 4. So now it's kind of here. Is that okay with you? Mm-hmm. And then I labeled my axes kind of well there. It's shifted to the right 4. It's shifted up 11. And now I should just draw a parabola. Wait a minute. One more thing. He's upside down. So I'm just going to draw him upside down. And that's kind of quick and easy and rough, but it's pretty darn accurate. You're powerful, I'm telling you. When you learn this, memorize these 5 basic functions and how to shift them, you're powerful. You can graph stuff. You just know what stuff looks like using these ideas. You don't need graphing calculators. Throw them away. Revert back to the good old days. After we sketch this graph, I could try to ask you about some previous ideas. I'm up in 2-4. I think I've spilled the beans on all of 2-4. I think we should practice some more stuff. But as this comes together, I could go back to 2-1 or 2-2. I could ask you, does this guy have a minimum or a maximum? What would you say? It's got a max. It doesn't have a min, really. Right. It has a max. Where is that max? And then you might say, what would you say then?
11.
Okay. You could say it's at the point 411. You could say it has a maximum value of 11 and it occurs at 4. That's sort of how we talked the other day in the book. The homework might talk like that a little bit. But it has a maximum at the point 411. Yeah, it has a maximum at the point 411. It has no minimum. Is this function increasing or decreasing? When is it increasing?
It's not.
Is this function ever increasing?
Less than 10 to the 4. Negative
Infinity.
We talked about that yesterday at the end of class. It's supposed to be easy, but it takes a little thinking. It is increasing. If you think left to right, it's increasing. It's increasing. Even though these arrows are pointing down, it's as we work our way left to right, we are increasing until we get to this point, until we get to 4. Mm-hmm. So I would say it's increasing from negative infinity to 4. Those are the x values when it's on the rise, when it's increasing. That's how you say it. It's not that hard, but it takes a little thinking. What about decreasing? It's decreasing after 4. See, when you refer to the increasing and the decreasing, we're referring to intervals on the x-axis. So we're not even thinking about the y's, although it does increase and decrease to and from these y values. We're talking about the x values where it increases and decreases. So it decreases from From 4 to infinity, it's decreasing. It's on the decrease from 4 to infinity. I mean, these questions here now, I'm back, now I'm in 2.1, referring to a few things I did yesterday. But I don't want to, I just thought I'd make that connection. Let's try another one. I'm gonna get rid of these notes here a second. Some of these notes. Let's try another one. Watch this guy. F of x equals x minus x plus 5 cubed. Well, there's not a whole lot going on there. It is somebody cubed, but there's not a lot going on. I don't think, do you see an up or down shift? I don't see an up or down shift. Do you see a flip, a sideways flip or an up? No, I don't see any of those. The only thing I see is x plus 5 in parentheses. That means
To the left.
I'm shifted to the left, 5. That's all that's going on. So, okay. So if I had to describe that in words, I would say shift left 5 units. Okay? So there's me using words, but I really would like a picture of it. And so I will go to the left 5 units and I will sketch the picture of a cubic function. It's a cubic function shifted over to the left 5. Here he is. This cubic function is interesting. It comes up to this point, and for just a second it sort of levels off, but it's only for a moment. So sometimes when I draw it, it looks like, I mean, look, it's really not remaining constant. We had that discussion about remaining constant for a while. Anyway, these are not remaining constant. These cubic functions are, if you want to call them constant, they're only constant for a minute or for 1 point, which means we don't call that constant. So they're not, they're not exaggerated like that. They should be. This is a pretty good picture. They come up here, they level off just for a second, and then they continue. You know what they're doing right there? This is kind of a pre-calculus, calculus topic. I won't really ask you about this, but I might as well use the words here. You guys are smart. It's changing concavity. That's what it's doing. Watch this. I mean, just because I said the word calculus, don't freak out. Listen, it's concave down, and then when it gets to that point, it changes to concave up. It's just the bend. It's concave down, and then it's concave up. It's either spilling water or holding water. And at that point right there, it's changing concavity is what it's doing. But anyway, so that was easy. Sketch a graph of him. That's all he had. Shift left 5. That's all he is. Let's try another one. F of x equals 32 minus the square root of x plus 47. Hey, if the numbers get big, does that scare you? Well, they're still just numbers. So just these things can be, it doesn't matter. They're just numbers. Doesn't matter how big they are. It could put 1,200. And so it doesn't matter. It shouldn't matter. But anyway, let's talk about this one. This is this square root guy. I guess I've erased his basic shape. I'll remind you. A square root guy's basic shape is this thing. It's kind of half of a sideways parabola, the top half of a sideways parabola, you could say. But that's his basic shape. Now, this guy's been shifted like hell here. Let's talk about his shifts. What would you say about what? What would you say? What would you say about that 32? I might be confusing you a little bit. I sort of am on purpose. What I did was I added the 32 in front instead of on the back. Listen, I mean, in my notes, it's the function plus 32. Well, when you add a 32, I added it in the front, kind of. I've got 32 plus this function. I mean, it is a positive 32 added to this function. It's just kind of in front instead of on the back. So I would call that 32 a shift up. Is that okay?
Mm-hmm.
What did you want to say? You were trying to ask me.
Oh, I was going to ask if it was a shift up with the flip upside down.
Well, good. So the 32, I mean, right, students do, they get this confused a little bit, but you got it. The 32 is positive. I mean, if it was a negative 32, I think I'd call it a shift down. But so it's a 32 that's positive, so it's a shift up, 32. And then that negative sign is not on the 32. The negative sign is sort of in front of the function, and we know what that means. The negative sign in front of the function is what he said. That's the flip upside down. So he's right about that. That's flipping it upside down. Anything else, you guys? The plus 47. The plus 47 is in there with the x. You see that, right? Even though I didn't put parentheses, it's in the square root with the x. That's not up or down. That's left or right, and it's left 47. So good. Well, and all I got to do is take this picture and do that. That's it, right? This basic picture and do that. So I got to go up 32. Look how I do it. I go up here and I call that 32. That's how I do it. And then I go left 47. So to be accurate, I'm going to go, if that's 32, roughly that's 32. Are you with me? I mean, I want to go 47 is a little more, so I'm going to go over here and call this negative 47. I went left, it's left 47. It's a negative 47 is how it should be labeled, I guess. So that's awesome. He got moved up 32. He got moved left 47. Here he is, except, wait a second, I forgot one thing. I should draw him upside down. And that means he's flipped right upside down from where he is. That's kind of why I don't like the word reflection around the x-axis, because I really don't reflect it way down here. That's not what I'm going to do. I'm going to flip him upside down. And so he's right here, and now he's flipped upside down. And if he's flipped upside down, he's now this. Do you agree? Mm-hmm. Okay, awesome. Awesome. That's it. It's a square root function. You got to see it. It's a square root function, shifted up 32, over 47, and flipped upside down. You know what's a good question now? Here's a good question. Just to add to this at the end. What's his domain? What's his range? That's not always an interesting question. In fact, on some of these, I'll tell you what, let's stop just a second. Go back to this picture. Can you tell me his domain? This is a cubic function, as you can sort of tell. It goes up forever, it goes down forever. And as it goes up and down, it continues to spread out. So what x's do you think it spreads out over?
Negative infinity, positive infinity.
Yes, so the domain is all real numbers. Negative infinity to positive infinity, she said, or you could use the phrase all real numbers. What about the range? What kind of y values does it get to? All real numbers, yes, ma'am. Negative infinity to infinity, right. So this function has an easy domain and range, or you could say, or maybe that confuses you, but it's all real numbers for both the domain and the range. But this guy does have this endpoint. That square root function has this sort of starting or stopping point. So its domain and range are hugely influenced by where it starts and stops. So can you tell me his domain? He doesn't go back this way. I guess his domain is all x's greater than or equal to, yes, I'm going to say x greater than or equal to negative 47. That's what I'm saying. To the right of negative 47. Those are this function does not live anywhere to the left of negative 47. There's nothing there, right? Right. You want to say it a different way?
Negative 47, comma infinity?
Yes.
Okay.
Put a parenthesis on infinity. Put a bracket on that negative 47. That's okay. Either way. Hey, what about the range?
32.
It never goes higher than 32. So the range is everything less than or equal to 32. So the range is y values less than or equal to 32. Is that okay with you? All right. See, I think if you talk like that, I don't know, it's a more logical way to talk. And when you try to do the interval notation, you can get yourself a little screwed up. But maybe but I don't know, maybe you prefer it. Some people don't do well with this and they prefer this interval notation. How would you write this in interval notation?
Negative 32.
Right. I would write negative infinity, comma, 32. You know what a lot of people do, though? I'm going to just say this. For the range, they would write 32, comma, negative infinity.
Yeah.
I don't know why, but listen, there's something slightly wrong with that. I mean, I get you. You're doing your best. You're trying to explain it to me, and you got the right numbers, but when we write this interval notation, the lower number should be on the left, and the higher number should be on the right. And negative infinity is lower than 32. I mean, we should write it like this. This is not really right. It's really kind of backwards. We should have the lower number on the left and the higher number on the right when we write our interval notation. That's good, though, you guys. What did we do? Please graph this complicated function. I mean, that's wild. You couldn't do that an hour ago. Now you can. Graph this complicated function using the knowledge of the basic shape of the function and how to shift them. Okay. Oops. There's another way to do this. So I'm gonna stay on this topic. Although we're almost done with this topic, I'll just stay on this topic. I can ask it to you backwards. So what have I been doing? I give you the equation, ask you about the shifts, and make you give me a graph. Okay. A backwards question is, what if I give you this graph? Watch this. I give you this graph, and I label it for you pretty well here. Look at this. I'm giving you this graph. I'm going to label this 100, and I'm going to label this 90. And I'm asking you for the equation. Find the equation. Find the equation of the function. Or find the function is one way to say that. So I think you should write f of x equals, and now we got to come up with the function. And you know, we have these 5 basic functions. Which one is he?
Absolute value.
He's that V shape, so he's that absolute value function. So good. Look, you might get partial credit if you do that. Not much. Not much partial credit, but you know something. You know it's the absolute value function. Now, how has it been shifted, and how are you going to write it? I guess it's been shifted to the right 100. So how do you write that if he's been shifted to the right 100?
Minus. No. Yes, minus.
So what are you saying? Inside the absolute value, I should put, what should I put inside it?
X minus 100.
Yes, thank you. He's right. That's what I got to do. I mean, there's an X in there. Some people forget about the X. They put a minus 100 in there or something. It's an X. That's this guy shifted to the right 100. See, I guess you got to remember what he is. When he's very basic, he's this, right? Maybe this would help you. Okay, he's a V shape, so here he is in his basic form. Now we're going to shift him, so we need to put the minus 100 in there. What else do we need to put in there? A plus 90. And that doesn't go in there, but it goes out on the end, kind of, and I could add it to the front or the back. I'll just put it plus 90. That's a shift up 90. That's to the right 100. That's good, you guys. Is there anything else?
Negative
Good, he is upside down. You may forget to recognize that, but yes, he is upside down. So if he's upside down, you better put a negative in front. Awesome. That's a backwards question. I gave you the picture and wanted you to come up with the equation. You know, it's the same concept, it's just backwards. And sometimes it's harder. I mean, sometimes, I don't know, you're used to working one way. I like you to work both ways sometimes. What about this one? Find an equation for a parabola with a maximum at 17, negative 23. Dun dun dun. This is tough. No, it's not really tough. It's the same old stuff, but it's worded differently. This again, I want you to find the equation. I guess I did not give you a picture, did I? This time, over here, I gave you a picture and said, come up with the equation. This time, I'm asking for the equation, and I didn't give you a picture, but I described it pretty well. If I was you, I'd probably go draw a quick picture of this. Where is this point? I would go find this point so I could kind of see where it is. It's 17, negative 23. It's over here 17, and then it's down 23. Is that okay with you? So there's this point, and is that a minimum or a maximum? It says it's a maximum. Okay, well, so that's a maximum. So that means I gotta, and then what's my shape? My shape is I use the word parabola. I mean, again, I haven't used that word much, but that's, who is that? You know, that's that squared function, that x squared function. So you're saying here he is. So now you drew him, but so what? You don't get any partial credit for that. No, I wanted the equation, but I think drawing him helped you think it through. I bet you now you could write the equation. I bet you could. So it's something squared. Look how see how I get started? I know it's that squared thing, so I just start by saying it's something squared. Now how's it? What should I put in here? X minus 17. Does that really work? Because that's a shift to the right 17? Mm-hmm. Okay, then that works. What else do I need to do to it? Put a negative out front because it's upside down? Yeah, you're right. You're right. And what else?
Minus 23.
Oh, put a minus 23 because he's been shifted down 23. Yeah, good. You found the equation of the thing I was asking for. Yeah, you did. That's awesome. Okay. I might give you a few more notes. Do you guys need a little break? We're sort of past our break time. I'll tell you what, let's just keep talking here a few minutes. Maybe we'll just get out early here. Can we do that? Yeah. All right, we'll keep talking. We'll skip our break, but we'll get out early, I think. We'll get out early. So I will talk about these notes real quick, although this whole subject gets a little more complicated if you do start talking about that stretching and compressing. But I'm going to say this. If you have a letter A multiplied by your function, that's going to stretch or compress. And the deal is, if A is kind of less than 1, oh boy, hold on. I'm going to say the absolute value of A is less than 1. Then that means that's like, it's like a 1/3 or a 1/4 or a 2/5, or it's something less than 1. And therefore, that makes it wider that makes it wider. I'm going to say it compresses the function. Compresses the function. But that sort of squashes it and makes it wider is what it does. If that if that multiplied a is bigger than 1, then it's like a 2 or a 3 or a 7 or an 8. Then it's got stretched and it's skinny as hell. So it's either skinny or wide. That's called stretched or compressed is what that is. So now it's stretched. And it's how much is it stretched? See, that's the thing. It makes it a little tough for me to grade. I can grade the shift. The shift is down 23 or over 17. It's just kind of skinnier and kind of wider. You know what I mean? I have a hard time grading the official accuracy of your stretch or compress. That's why I'm whatever. I don't really want to test you on it. I want to tell you about it. It's kind of cool to know, and we kind of need to know it, but especially as we progress through this semester. But I don't think I want to really test you on all those details. But that's good. That's good enough. Hey, why did I use absolute value on this A? Do you know what I'm doing here? Because I don't want to discuss the negativity of it, because if it's negative, what is that doing? That's the flipping. So if it's a negative number, that's the flipping upside down or not. So the negative is the flipping. The size of the number is what I'm concerned about, whether it's a 1/3 or a 1/5 or a 5 or an 8. So I'm not concerned with the sign on the number. I already know what that does. I'm just concerned with the size of the number, and so I'm ignoring the negative sign if it has one. Check this out. This is weird, I'm sorry, but if you have that A multiplied by your X, then it's, so this is this is a compress and a stretch, but this is a vertical compress or stretch. When it's multiplied by your X, check this out. Now it's a horizontal stretch or compress. So now you compress it this way or stretch it out this way. And it's opposite of what you would think. It's opposite of this one. So if these are my notes say that if the absolute value of A is less than 1, now it's a stretch. It's a horizontal stretch. Horizontal stretch. What was it up here? A compression? A vertical compression. But down here it's a horizontal stretch. What if that absolute value of A is greater than 1? What if that A is bigger than 1? Then it's a horizontal compression. This is pretty technical, and again, I don't know about this. I mean, I don't think I want to test you on it, but you may see it in your homework, and it took me 3 minutes to tell it to you. It's not a big deal. You might see it in pre-calculus. Go to the next class. Good. So there is one more idea before the test on Monday. The test is Monday. There's one more idea in section 2.5. It's called variation. I think I won't do that today. I think I got a couple days to get to it. So what are we doing tomorrow? We're coming in tomorrow. I'm hoping maybe you got some questions tomorrow. I'll try to answer some questions. One reason you might have questions is because I'm going to hand you something here today to work on. So I'm going to hand you this and let you take it home and work on it. So you might have questions on this tomorrow. And anyway, we can answer questions for a while. If we get bored, I might push into 2.5. But then we're taking a quiz the second half of class. So then what are we doing Thursday? I'll give you those quizzes back and we'll talk about whatever else we need to wrap up, whatever other questions still remain, and prepare for our test Monday. Yeah, we'll be fine. We're in good shape. We're not doing a bunch of last minute stuff Thursday. This thing is 4 pages. It's a lot of questions. And it's called Chapter 1 and 2 Practice. Okay? But it also is says practice and take-home quiz. So, and then it says it's due Monday. So it's due Monday at 10 o'clock, the day of, the time of our test. It's due Monday at 10 o'clock, and when we come in here and take our test. And it says, I will randomly select 4 of these questions to grade for a take-home quiz grade. So we're doing a real in-class quiz tomorrow, and that'll be a 1 quiz. But then this is a take-home quiz. But I randomly picked 4 problems. So now, are you a gambler? If you're a gambler, you only have to do 4 problems, and you hope I randomly select those 4 and you do good. That's not really what you should do, probably. Because whatever I don't grade is called practice. I mean, this is good practice. This is in my test Monday. It'll look a lot like a lot of this stuff, I think. So please practice this the best you can. You do have to turn it in. If there's something you don't get or can't get, maybe I randomly won't select it and it won't hurt your grade, although if you don't get it, it may show up on the test and hurt your grade. You want to understand all this, of course. And you got time to ask me during class, ask me after class, ask each other. You can work with each other. Listen, I like to give take-home quizzes and I like you to work with each other, but there is an integrity issue. It's hard to regulate when it's outside of class. I have to trust you and your own integrity and your own honesty to try to help each other without giving each other stuff. So can you talk about number 4? And you can say, I got this answer, you got this answer, let's look at it. You can discuss. I love that. You can learn. But you can't say, here's mine, copy mine. I mean, you can't. Anyway, you can't do that. You just can't do that. But you can. So you can honestly help each other. You can't dishonestly help each other. There's also, I crammed all this into 4 pages, so there's not a lot of room for you to work on here. And some problems there might be, because there's not a lot of work, and then some problems, anyway, so I don't know. You may want to be working on other pieces of paper. You are turning this all in, so some neatly organized way of turning this in would be nice. If it's okay, if some of it's on here and some of it's on other paper, if it's numbered and labeled, and you turn it all in, and then I'll randomly find your 4 problems and grade them. Should be a good quiz grade. It should be good. I might even help you with some of them. You know what I mean? Over the next day or 2, you might say, you help me with number 7? And I'll help you with number 7. If it turns out number 7 is randomly graded, then I just helped you with number 7. It's okay. But anyway, we don't know how it turns out in the end. Okay, good. Sometimes I hand out these take-home quizzes and I don't really explain their purpose. So now you know their purpose, and if you get one in the future, the same kind of rules apply. But I'll just let you take one of these, and we can just quit today, I think.